So again, we want the volume of the sphere. Well, we take the limit as all your delta x's, delta y's, and delta z's here go to 0. Limit of these sums, and it leads to a simple integral. Okay, so it's a limit of your triple sum, and I'm not going to write all the limits here. They're the same as they are there of your delta x, I delta y, ij, delta z, ij, k's, which equals triple integral. Now, x has the fixed limits 0 or negative r to r, right? So we have to have our fixed limits outside. We never want to have variables in our limits that we've already integrated. And hopefully you've done enough problems to understand why that is. It becomes very obvious. If you do it wrong, it really gets very confusing and you say, oh, duh.
And you come out with something other than a constant?
Yeah. Yeah, you got a volume and all of a sudden your volume has these variables in it that it can't have. Okay? Or an area or whatever you're trying to get, or a moment of inertia. Okay? So, your first integral will be with respect to x, your outer integral, right? And then you'll integrate, have to be with respect to y, because your z limits are going to depend on y, right? On x and y, okay? So it's going to be with respect to y, and then with respect to z. Because your z limits are from negative square root of r squared minus x squared minus y squared to the square root of r squared minus x squared minus y squared. Okay? And your y limits are from square root of r squared minus x squared to the square root of r squared minus x squared. And there it is. And you just do the integration. You're going to be doing some trig substitutions. You're going to get good at trig substitutions. Okay?
I'll have to
Make
look
sense?
at those again.
Huh?
I'll have to look at those again. Wait, knowing which ones
Yeah,
to
well, you know,
substitute.
after multivariable calculus, you kind of never forget them if you do all the homework that needs to be done. Okay? Now, I'll leave it to you to see that the integral that you get for the volume here r goes from 0 to big R, right? Theta goes from 0 to 2 pi. And z goes from negative square root of big R minus little r squared to the square root of big R minus little r squared. And the reasons are much the same as they are here, but it's much simpler in this case. Okay?
You just have an r squared instead of an x squared, y squared.
Well, x squared plus y squared is r squared, right? So z is still going from where it does to where it does, okay? But we don't use
Right.
r for variable here because it's not one of the variables that we use in rectangular coordinates, right? So you begin to see relationships, and that's good, okay? And then when you set up the integral in spherical coordinates, your volume increment is a little more complicated, okay? Rho squared sine theta d rho d theta d phi, right? You just did spherical coordinates, you should know. But you will, okay? Make sense? Okay? So you just have fixed limits. Okay? Rho is going to go from 0 to big R, theta is going to go from 0 to 2 pi, and phi is going to go from 0 to pi. Full range, and you get the whole sphere. So you have fixed limits out here, and the order of integration doesn't matter. The order of integration here between the dr and the d theta doesn't matter. Okay? But again, you got to make sure that you don't use any variables at some point that have already been integrated. Again, you'll pick up on that. Okay, hopefully I won't have to make a note on your homework on that.